experienced that, to be sort of, to be the foreigner in at home was a nice experience.
All right, should we get started?
Yes.
Yeah, sorry.
And because since you don't have video, if there are things on screen that you're curious about, just pipe up and I'll try and describe it as well as I can. And
I'm recording this, so
okay.
watch it later. So all the conversation we just had is recorded.
Oh, great, wonderful.
I will chop it out before we show it on the web.
All right, introductions.
You want me to introduce?
I do.
Okay, so I am very happy today. We have Chinmay Kulkarni. Did I pronounce it right?
Yep.
So he's working on like future of work and how you facilitate people collaborating. And I'm excited to see what he's going to show us, because it just, we all working and we all looking forward to the future, and we are doing hybrid and all kind of stuff. All right, so I'm going to shut up and let Chinmay take it over.
Thank you, Alan. Thank you for inviting me. So today I want to talk to you about, as Alan said, about the future of work. And in particular, I want to talk about how computing is changing work and how we can change computing in order to create a better future for work, right? So to begin, I want to show this result from a survey. This is sent out to about 5,000 US workers every month. And one of the questions on the survey asks the respondents, after the end of this pandemic, how frequently does your employer plan for you to work from home? And you can see here at the start of the pandemic, as employers are putting in the technological infrastructure to make remote work possible, they expect people to work maybe a day or a day and a half. But now that the cultural infrastructure and the technological infrastructure is in place, employers expect workers to work from home about twice as frequently, with the result that that workers who can will spend about 40% of their work week working remotely. And again, this is after the end of the pandemic. And almost certainly a lot of professions are going to be completely remote. So this is a large and fundamental shift. Another large and fundamental shift is how computing is changing employer relationships with employees. So instead of work being an exclusive, long-lived commitment between employer and employee, more and more work is becoming a series of well-defined small tasks that people complete. So instead of hiring a designer full-time, you can go onto a platform like Fiverr that I show on the top right, top left here, and you can hire someone to design a logo for your business for maybe a day. Or you can go to a platform like Upwork and you can hire someone for maybe a month to design the app or the website around your business. So this isn't just a cute change. This is a large fundamental shift in how we work. We have more than 50 million freelancers working on platforms today, like the ones that I've shown you here. And they've earned over the last year at least $25 billion. So this is a large change. And I think put together what these two changes represent is a fundamental shift. And we're creating this future of work where work is both computer mediated and taskified. So regardless of whether we like it or not, this is the future of work that we're creating. And unfortunately, I at least think that this is a future of work, but it's a future of work without meaningful social interactions. So what we've seen is that we've designed these computational work environments that increasingly mediate how we perform our work, but they mostly see work as tasks to be completed. You know, platforms like Upwork and Fiverr and all of the others that I've shown here, they actually pay people per task completed. But even if you aren't on these platforms, even if you're using all of these other tools, some of which you're, I'm certain, using at Colorado, they are focused on task completion. Right? They aren't really designed to help you with the informal, the haphazard interactions that have characterized our work. So as a result, what's happening is that tasks are getting completed, but learning and inclusion and career growth to some extent are suffering. So my argument through the rest of the talk is that if we want to have learning and inclusion and career growth, we're going to have to design it explicitly into these new computational work environments. to make one final pitch for why this is really, really important, I want to point you to a study from Microsoft that was conducted earlier this year and published in the Nature Human Behavior. And this study looked at how in the February 2020, 61,000 workers from Microsoft were forced because of the pandemic to work remotely. And what it finds is that over time, the collaboration networks between employees became much more siloed and static, and innovation in learning suffered. The informal colloquial headline result from the study is that Microsoft's social network got frozen in time in the February 2020 and has not evolved since then, right? So that's the future that we're creating, and it's a problematic future. We know that it's problematic from a long time. We know that email prevents rapport from being established, and without face-to-face interactions, we have less mentoring. And if you go back even to the 1970s, you see that open-ended work depends on having skills that are learned socially. So the research agenda for my group is to design computational environments explicitly to enrich work with social interactions. And my long-term 10-year wager is that we will be able to do that better than the haphazard interactions that we have seen in traditional work. I'm taking this wager because I have a secret weapon. And my secret weapon is our approach to how we build these systems. The way we do it is that we use findings from the behavioral sciences, especially the learning sciences and social psychology, to create interactions that scaffold learning and inclusion. And once we do that, we use computational techniques to improve the benefits, to amplify these benefits and weave them into work contexts. And because we are using computers, we can improve on what's possible in the haphazard of traditional work. And my wager is that we'll continue to improve on this over the next decade. To give you a sense of the stuff that we're doing in our lab, I want to just give you a few example systems that we have built. We build systems which we deploy at large scale. We run studies at large scale and see whether they're effective at large scale in the wild. So we've built systems for working with peers online, learning conceptual skills from them, which I'll talk about today, building systems for inclusion in the online workplace that I'll also talk about today. We've also built systems that provide in-context task assistance, and these can be multimodal voice assistants. We recently built one with Mozilla. It's called Firefox Voice that was integrated into the Mozilla Firefox web browser. And there are a lot of others that are not on the screen. And finally, we want to help other research groups and practitioners build systems like the ones we do. So we spend a lot of our time creating design tools, design methods, and frameworks to see how these can be used by other researchers. There's some here on screen. I won't be talking about them today, unfortunately, but there's some papers here that you can take a look at. So we've built all of these systems, and we've been very fortunate that we've been able to influence the work of organizations large and small using our research results. So organizations like Coursera and Instagram are directly using some of our research results. We worked with Mozilla to build the Firefox voice assistant, but we are also working with small local nonprofits to help them change how they see the future of work. And as I said before, because we build systems that are used at scale directly, we've had about 50,000 learners use our systems and benefit from them the last 5 years directly. So I want to talk a little bit about some of the methods that we use, and I want to dive deep into 2 more projects. So at first, I want to give you a little bit a sense of how we go about building these tools and putting them into the world. This is a new project that we are working with a Pittsburgh-based nonprofit firm, and they are trying to solve this large societal problem of how do we improve sexuality education, sex ed, in classrooms around the country. And what we do here is that we build the prototype, the system that in this case is this role-playing choose your own adventure game. And then the nonprofit is building the content for this choose your own adventure game, and they're creating a support system around it. such that it can be used by people from around the world. Okay, so that's one. Another common model in which we work is we work at small scales. In this case, this is my student Yasmin. She worked with this local feminist incubator to help designers think of new ideas and get feedback on new ideas. Here's one designer here who used this product that she built to get feedback on public art that was later exhibited in Pittsburgh bus stations. So this was a project that was in collaboration with Instagram. And so what we did after the end of this project was to distill down design patterns that Instagram could then use in their product to help entrepreneurs from around the country to get feedback on their own work. Okay, so I could go on and on talking about all of these projects, but today I'll just focus on 3 projects in 3 different areas. First, learning from peers in the future of work, creating spaces for inclusion in this future, and opening up remote work to more people. So the first project I want to talk about, it's called Juxtapure. It's about learning from peers. I want to go back to this example from a few slides ago, where I told you that you could buy services from which are taskified. So on this platform, you could have someone design a logo for your business. And so in order to design a logo for your business, the person who's doing the work has to be able to answer questions like, how do I design a logo? And they can go to a lot of online classes like Coursera, whom we work with, and Udemy and others, to get that systematic knowledge about how do you design a logo. But there's a deeper problem. They also need to know what makes a logo a good logo. What is good design, after all? And that is much more challenging to learn systematically. So in traditional work, workers have learned skills like design and software architecture, maybe even negotiation, through years of informal apprenticeship. So if you're a software developer, you work with someone who's more senior, they look at your code, they help you see features of your code that you didn't notice, and you become wiser over the years. But if you are an online freelancer who's working from task to task to task, you don't have this informal mentoring. So the research challenge we have is how can we scale these learning benefits of informal apprenticeship to online workers who lack these organizational supports? So some of my prior work is on peer feedback, and I built the first large-scale peer feedback system for Coursera in 2012. So I think of peer feedback as a potential solution, and it scales wonderfully. It scales easily with the number of peers. But even though I'm a booster of peer feedback in general, I know that while peer assessment and grading can be very accurate, peers generally don't notice the deeper structural features that you would if you had more experience. So the feedback that they give you tends to be based on superficial features instead. So the research challenge then becomes, how can we help peer reviewers notice these deeper structural features that help you answer questions like what makes a logo a good logo? So we designed the system. It's called Juxtapure. Here's a screenshot. Here's someone who's learning principles of good typography. The way this works is that people upload a piece of their own work, and others give them feedback on their own on that work to help them improve on the skills which constitute typography. The underlying principle behind Juxtapure is this idea of contrasting cases. And the idea is that instead of, when learners look at multiple examples instead of one example at a time, they learn more. So for instance, if you're learning about wine, if you just taste wine one at a time, you might just be able to say it tastes like wine. But if you're doing a wine fly and you say, is this wine sweeter? Is this drier? Which one tastes of pencil shavings, right? So you notice the deeper and more structural features by comparing. So we talked about wine, but we see that conceptual learning and design, business management, even things like algebra can be improved by using contrasting cases. So Juxtapure uses contrasting cases. And in this case, what we ask is, people upload work, and then we ask their peers to compare it with other work that we find. And as a result, we hypothesize that people will be able to see better feedback from the work. To find the right contrast, we are actually using the insight that we can use these peer comparisons to actually see what work is similar to what other work. So here we are asking peers this question: overall, do we prefer the work on the left or the work on the right? And then we're learning this linear ordering of peer work, which says these two pieces of work are very similar to each other. So we should ask people to compare those pieces of work. In this case, we use an active learning algorithm for ranking. You could use a clustering algorithm. The hypothesis that we have, regardless of whether it's clustering or ranking, is that comparative comments help people learn through deeper feedback. And to see if this hypothesis is true, we ran a controlled experiment. In this case, we ran it in 4 online classes, which taught topics like design and typography. I'm showing you this typography example, which was one of the classes we tried it in. So about 470 people enrolled in this experiment, and we showed them one of 2 conditions. Either they saw work one at a time from their peers, or they saw work 2 at a time, right? So as pairs, and then we asked people to compare. In both cases, they saw the same number of examples. Here's what we found. We found that learners actually do notice deeper and conceptual features. One way that we look at this is to compare the comments that they wrote with expert comments to see what kind of vocabulary they used. And learners use more expert vocabulary if they have comparative comments, comparisons to make. You also notice that peers write more detailed feedback. And overall, the ranking is very similar to the ranking that staff have for the same work, suggesting that they're actually comparing left versus right on these semantic features. So here, I want to give you one example of a learner comment to show what I mean. Here's the learner comment on this specific example of these 2 typography posters. Here, the learners, one of the peers says, "I love both pieces. The only reason I preferred the one on the right was because of a personal preference with stark contrast." So they notice features like contrast, which are more structural than just black or white. They also love the use of letters to convey composition and theme, other deeper features that they noticed. So we tried it in 4 online classes. And then over the years, we've tried it in more online classes. And over the last 3 or 4 years, we've had about 15,000 people use this in classes as varied as design and composition for music, management, case studies, and so on and so forth. Now, this isn't the only way to learn from peers in the future of work, but it does suggest that if you are able to use principles from, in this case, the learning sciences to help learn with contrasts, you can improve learning in the future of work. The second system that I want to talk to you today is about creating space for inclusion and learning from differences. This is not a new problem. Prior work has explored how we can help people discuss, collaborate, deliberate more inclusively. I just pulled this one example from 2009. It's a system called GroupMeter, and it helps people who are having a chat discussion to have a more inclusive chat discussion, right? So this is David, Ayumi, and Kathy talking about a particular question about what should happen in the playground. And here, down here, you see this visualization, and you see that, you know, in terms of word count, David's doing most of the talking. Kathy is hardly saying anything. And even when she does say anything, she doesn't really agree with what's happening in the conversation, right? So this is a conversation which, you know, if once David, Ayumi, and Kathy see the visualization, hopefully they start having a better conversation. Maybe David will speak less, Ayumi can speak more, and they can agree. But actually what this paper found was that visualizing group level agreement leads to people expressing agreement with the majority opinion without actually agreeing with it, right? So they just say they agree, but they don't tell people when they disagree. And so other work has looked at, okay, what if instead of showing this publicly, we turn it into a private message to Kathy and tell Kathy, you should talk more. And actually, once you do that, this research finds that with speaking hints, the team members actually start building artificial consensus. So not just do they not tell people what they think, but they actually start building consensus, which is a fake consensus. So not a new problem, an old problem which has been hard to solve. And really the question is, why isn't Kathy speaking more? And the reason Kathy isn't speaking more, I think, is because establishing rapport is hard. And it is harder in text-based online communication. Trust is hard. And without trust, members are unlikely to really believe that their voice matters. And so we have this culture of organizational silence. I will say that the organizational silence problem is not unique to online work. If you go to my condo board, there is an organizational silence there. Everyone knows something is wrong. No one says anything. And so it's a common problem, but maybe we can do something, at least in the remote and online world, to make it a little bit better. And so here's something that we built, and our insight here builds on this finding from social psychology, which suggests that if you want to improve safety, if you want to reduce this organizational silence, it helps to think of each other's perspectives. And in particular, it helps to think about not what people are saying, but how they are feeling. So perspective taking improves when you think about affective states. So to give you a little bit more detail, I'll go through some of the stuff that we've built. This is like the example I showed you earlier, a chat-based system. And it's a pop-up that shows whenever the team is trying to make a decision. And so this pop-up lasts for about 2 minutes, and I'll go through the 2 minutes of what it does. So the first thing that this pop-up asks is, it asks each member of the team privately, how do they feel about working with other people on the team? Then it asks them to guess privately how other people might be feeling about working with the team, again, from negative to positive. So it might ask me, how is Mark feeling? How is Jill feeling about this, this meeting? And here's step 3, where half of the magic happens. It shows each participant an average of how the team is feeling. And finally, the other half of the magic, we show each participant privately how well they guessed other people's emotions. So in this case, I guessed people's emotions at 46%. So I'm not very accurate. Okay, so all of this takes 2 minutes. And now the question is, what can we do in 2 minutes? It's fast, but is it any good? So in order to answer that question, we ran an experiment in a campus Turk with about 24 teams with 100 people in all. In this case, teams are completing this task called the foundation task, where we ask people to distribute $500,000 among 5 project proposals. And these are things like building a homeless shelter, giving it to a museum, and so on. The catch here is that all of them are good causes, and all of them can use the $500,000. So there isn't a right solution to this problem. You really just need to compromise, and you have to create a solution that everyone's happy with. So this was a task. And so at the critical point where people are about to allocate the money, we either had them use our pop-up system, or we just told them to take a 2-minute pause to reflect on how the team is going. And so here is what we see in our system compared to the control condition. So in the control condition, we saw people write in their feedback after the end of the experiment. One person was not respectful of my ideas and made snide remarks about me being insecure. And you can see this creating this culture of silence. And empathosphere is the name of our pop-up. And it's in that condition, people said, I felt everyone could voice their opinions. No one was shot down unfairly. Similarly, other people in the control condition engaged with caution, trying to let some other team members bounce ideas, but no one was really into it. Again, this is silence, apathy, the problems that we see in groups all the time. Here we see in the empathosphere condition, I suggested an alternative allocation. The group reached an amicable decision-taking, everyone was hooked, right? So it's much more democratic, it's much more inclusive, it is much more engaged. So these were how people felt. I also want to talk about how happy they were with the solution that was chosen. So in the empathosphere condition, a pop-up condition, people were happier with the solution, about 10% more, right? So 2 minutes of an activity led to a 10% higher satisfaction with the solution. There were some marginal effects where people were also more likely to be more willing to give feedback and more likely to receive feedback as well. Okay, so this is a 2-minute intervention, and it's a good start, but I'm not going to say that we have solved the problem of organizational silence. But I do want to suggest that short and theory-informed interventions can be surprisingly effective. And because they're surprisingly effective, they create all of these open questions. Like, does this effect fade over time? Do people stop paying attention, or do they start to not need this tool anymore? Do they start paying attention to people's perspectives directly? Does it work differently for minority versus majority users? And more generally, in most workplaces, we have seen policies which try to improve inclusion. Now, if we have theory-driven interventions which improve inclusion as well, how should they interact with policies of the workplace? So lots of open questions. Maybe some of you have ideas on this. The last project I want to talk to you before we open up the floor is opening up remote work, online work, the future of work to more people. So at the start of this talk, I told you that you could get hired on this online labor platform for just a day for doing a particular task. But if you go into the details, it's really hard for workers to get hired today. And the reason why it's hard is because being hired for a skill on this labor platform needs reputation. And so if you want to be hired to design a logo, it helps if you have designed logos in the past. But when you're starting out, you have no reputation. So it's hard to break in. And even after you've broken in, if you don't get hired, you get no feedback. The people just simply ignore you. And so you don't know what you need to do in order to get the kinds of jobs or tasks that you would like to get hired for. So things are pretty rough if you're a freelancer on these platforms, but they're not great if you're an employer either, right? So here are the problems that if you are an employer, you need the expertise to hire in the domain that you want to get workers in, right? So if I'm a software engineer, it's easy for me to hire a software engineer because I can tell who's good. But if I'm a hairdresser trying to create a website for my new business, how do I know who's a good web designer? And if you want to take the asymptotic version of this problem, how do you hire a translator in a language that you yourself don't speak? And you obviously need a translator for a language that you don't speak, right? So here we have a challenge where hiring right now doesn't really help either the workers or their employers. And so the research challenge is, how do we develop a method for hiring experts in online labor platforms, which both do not have any involvement from employers because they may not know how to pick the right people, and doesn't rely on reputations. So you can have the ability to break into a new space. So here's one crazy idea based on our past work. What if we use peer assessment? In particular, here's what we think we should do. An employer or a requester, in this case, submits a posting to a job, and workers apply to the job. And then instead of letting the employer pick, we just ask workers to rate each other. And then we use those ratings to rank applicants for a job. So I hear that Atlas is hiring this year, so maybe you would get all of your job candidates to review each other and then pick the ones at the top. Okay. So what could go wrong, right? So one thing that could go wrong is that if you're a highly motivated applicant, then you might want to rate other applicants strategically such that you look higher in the rankings, right? So the way around this problem, the insight that we have is that we could use computing as a guardrail, right? So we can remove the incentives for dishonest competition. And instead of just taking people's rankings as they are, we can aggregate them in a way that we reduce or eliminate the incentives for dishonest competition. And the way we do it is we create these mechanisms for strategy-proof rank aggregation. And I'll say here what I mean by strategy proof because it's important. And what I mean here is that no person, player, applicant, I can affect the probability of being ranked in a position J for all of those positions. So no one can, through their effort of ranking others, change the probability of being ranked in a particular position. Equivalently, we have a value perspective, which gives you the same results. Now, even though I'm saying this, I will also say that for this particular project, we assume that there is no collusion among the applicants. We also assume that there's no Sybil attacks. And the last thing I will say here is that I'm going to give you a few algorithmic results, but I don't want to pretend that I am a computer theorist. What I do want to say is, by working with computer theorists, we've been able to solve a long-standing problem here, which I think paves the way to opening up the future of work. So the first thing that I want to talk about is, can we create a strategy-proof ranking algorithm? Here, I'll first show you it was possible. So to show it was possible, you can just choose a candidate at random, right? So I see Mike Rivera here. We'll just put Mike Rivera last, and then use Mike Rivera's rankings to rank everybody else in the applicant pool. Okay, so it's great because it is strategy proof. Mike can't change where he's ranked last. And the rest of the candidate pool can't change where they are ranked either, because Mike's doing all the ranking, right? So it's strategy proof. It's not great if you're Mike. Okay, so a more advanced version of this that we can do is to split up the pool of applicants such that everybody in one pool only ranks people in the second pool, right? So we partition people. So partition A ranks partition B ranks partition A, and then we interleave rankings. So rank 1 from A, rank 1 from B, rank 2 from A, and 2 from B, and so on. A little bit better, but we think that we can go a little, we can improve on it even more by showing you what's called this committee algorithm. And the reason why I want to improve on this partitioning algorithm is because the size of this partition, it determines how accurate your results can be. I will show you a little bit more at the end of this slide deck through results of simulation. Okay, so I'll talk to you about this committee algorithm, and hopefully Mike will be happier with the results. Okay, so the way this committee algorithm works is that we choose a random subset of the applicant pool as a committee, and then we have specific parts of the ranking results that are reserved for each committee member. So if you're a green committee member, you can only go into this part or this part or this part. Essentially, you can go into a spot which is 1 or 1 plus k, 1 plus 2k, and so forth, where k is the size of this committee. Then what we do is, for each member on this committee, we use the rankings of other members on the committee to find their rank. So maybe Mr. Green has to go over here. Unfortunately, Mr. Green is in a spot that's reserved for Mr. Red. So we'll push him down to the nearest spot such that he's in the right spot. The reason why we reserve spots here is to bound how far committee members have to move to their final ranking. Okay, so we do the same thing for all of the other ranking, all of the other committees, and we move them into the right spots. And now, since they're in their final spot, we use the ranking of the committee members to rank everybody else who's in the applicant pool. Okay, so this is a committee algorithm, which is first, it is strategy proof because we choose committee members at random. Each committee member's final spot is determined only by other committee members. And the spot of the rest of the committee is picked by the committee. So it's strategy proof. I won't go into the details of low, backward, and forward error. These essentially put a bound on how far the ranking will change if people change their mind a little bit, and how far a small perturbation of rankings, how far each person can change their ranking based on a small perturbation of everyone else. So I'm happy to talk more about this in a Q&A if you're interested. But I want to show you two results. First is a simulation result. Here we use a standard distribution model, and we show you here, the important part here is that this is the naive bipartite model with the two partitions, and here's the committee model. As the number of applicants increases, the committee model becomes more and more accurate because you're throwing away less and less data. So with 40 members, you see that the committee is almost can completely recreate the original rankings. The more interesting results are the ones in practice. So we ran a study on Mechanical Turk, and we gave people an incentive to lie. We told them that they would get a bonus if the thing that they, if the item that they picked was in the top ranked few, right? So we asked people to edit to edit a review for spelling errors, and then say which review is the most helpful. And if your review, the one that you changed the spellings for, is among the top ranked, then you get a bonus, right? So we incentivized people to sort of inflate the position of their item. And even when you do that, we find that we can recreate the original ranking of reviews by about with about 88% accuracy, even when we give people an incentive to lie. So essentially, through this work, we can show that strategy proof mechanisms can remove the incentives for dishonest competition. And in the paper, there's more about how we communicate these algorithms to people who are not algorithm or computer scientists. Okay, I'll say one last thing about this. We actually tried this out. We tried this out to hire someone to design banner ads for a research project we're creating. We just wanted to see if it has any benefits beyond simply being accurate. And so here's the ad that we had. This was an Upwork marketplace. People used our comparison interface to actually rate each other and give feedback on each other's applications. And we found that people found it useful in order to see how to showcase their strengths, right? So here, for instance, this person who says, I will choose a different way to represent my skills. I've chosen so far what I've thought to be great, but haven't thought to see what others would like to see. So this is the sort of thing that you would get from informal mentorship in the workplace. So it's much harder to get if you're working alone on these online freelance platforms. We also saw that people actually wanted to make changes to their resume and learn new skills to get the jobs that they wanted. So all in all, you can see how these mechanism designs can, these strategy proof mechanisms can open up many new opportunities in future work. But I'll also pause here to emphasize that strategy proof in this section doesn't really mean fair. It simply means that you can't dishonestly compete. These mechanisms are still vulnerable to all sorts of implicit biases that we see in the workplace. All right, so I've talked to you about some of the systems that we've built. I also want to talk to you about the stuff that you're currently building that isn't yet published. So the two areas that I want to speak to you about is designing for inclusion. This last part, which I said, strategy proof doesn't mean fair. We still have implicit biases. And these implicit biases are becoming more and more important as work becomes more distributed and remote. So there's this wonderful article called Zoom Ceiling, which suggests that people who are working remotely are less likely to be promoted. We don't have very good evidence on the statistics of this yet, but anecdotally, there's certainly a fear that this would happen, and that fear is pretty well founded. Minority members have a harder time learning informal knowledge in a workplace, mostly because they don't know whom to ask, and the social networks are homophilous, so they only know other people who are also minorities and not in the core. There's this wonderful paper called "The World is Not Small for Everyone," and it shows how there are invisible barriers to knowing who knows what. So one of the research challenges that we're tackling right now is how do we create systems that break through these invisible barriers that are faced specifically by minority members. One thing that we're trying to do is to create the Slack plugin, which creates these ad hoc groups where people are likely to talk to others who they don't otherwise bump into. The other project that I want to talk to you about is that so far I've mostly talked about knowledge work and online work, but computational environments are coming for all work, right? So even work that was traditionally offline work, like hospitality or food service, is now increasingly mediated by computers. So food service workers are often subject to a machine learning algorithm for shift scheduling. There's systems like hot sauce, which determine the paths that a house cleaner takes through a hotel. And unfortunately, none of these services, for the most part, are designed with workers in mind. So we're working in collaboration with Unite Here, which is the country's largest hospitality union, to create a new design process that centers workers throughout the design of these computational work environments. All right, so the last thing I'll touch on is teaching. And I think one of the things that I noticed when I taught this class called Human-AI Interaction was that there's a lot more creativity and a lot more potential for creating better systems for the future, if only we let more people do it. And so this class called Human-AI Interaction attracted people from all parts of this of CMU, from the art school, from business, and so on. And part of the learning goal for this class, which I think we did well on, was to empower students to think of themselves as designers, as critiquers, as auditors of future human AI systems. Okay, so in closing, I'll leave you with a question. I started talking about how computational work environments today focus on getting tasks done. But what if instead we could think of how they can make work better? And I think doing that has a lot of challenges that we can work on together. And I know that Atlas here is a very creative multidisciplinary place. So here are a few challenges that I put up for folks here at Atlas to think about. Like, in terms of good ideas, where do good ideas come from if you can't bump into other people serendipitously? How can we make the future of work for everyone? How can we make it accessible? How can we think about what algorithms we should be building? And finally, I have this long-standing sort of side project interest. Can we just say what we want is declaratively design systems for the future of work and have computers synthesize them for us? So with that, I'll say thank you for being a very patient audience, and happy to take questions. And thank you to everybody who funded this work.
Ooh, yay. Nice.
I don't even know where to begin. There's such a lot to think about.
I'll take the first question while other people formulate theirs. I just love this work. Thank you so much for this talk. I love all of the work. I especially love the empathosphere work because it's something I care a lot about. We're trying to develop this community. I want people to get along. Sometimes one student will think they're being incredibly kind and another student will think they're being incredibly condescending. And so one thing I noticed that you didn't include was, well, at least in the empathosphere work, I think any sort of assessment of the communication, it was just an evaluation of how you felt and how you think other people feel. And I wonder about that aspect, whether I'd love to say, you know what, let's run this conversation through the empathosphere and it'll tell you who's right.
I don't know. Okay, so there's two parts to that question. I think one of them was content analysis. Sort of, do we look at what people said? And we did, and we found that after people used that pop-up, the empathosphere, they used more second person pronouns. So they were much more other oriented. They also use more informal language. So I think that there is, this is more tenuous claim, but I think because they're using more informal language, I think there's more cohesion in the group. The other thing that we found, and this one, those first two made it to the paper, this last one didn't, was that people who guessed other people's emotions better were also happier with the solution at the end, right? So I don't know which way this goes, right? Is it that because you see how other people feel, do you change the solution to make them happier and therefore you're happier as a result? Or is it just correlational that, you know, if you're happier with the result, you also happen to be someone who is generally better at seeing other people, right? Seeing what other people think. So yeah, that one didn't make it to the paper, but yeah, it's a good question. So the second question you asked was, can we put a conversation through this system and it will tell you who is right? And that one I'm less hopeful about, because I don't think that there is a grounded, yes, you're right, and yes, you're not right, because I think much of what we've seen with perspective taking is both could be right. They could just not see how each other are right? So yeah, hopefully that helps somehow.
Yeah, that's great. Thank you so much.
So what I like, or I'm about to make the question or suggestion, right? So earlier when you talk about peer review and when people showing one more cases or not example, then people tend to compare or being able to offer more critique or having more depth or structure suggestion instead of surface level feature. But in your peer review of the resume or who is better, right? So maybe you should let people do like 2 at a time, right? Maybe
we do let them do 2 at a time, actually. So
cool.
I here, this is 2 at a time, right? So they're looking at 2 different applicants and they're saying which applicant has a stronger background in graphic design, who has a stronger background in advertising, and so on. So yeah, we are drinking our own medicine.
Perfect. So then you get the committee going, but each one of the committee, they don't just evaluate individual person, they do a pair. And then I'm not saying there should be a competition, but almost like, okay, between these two, this one's better. Between these two, this one's better. And so all the committee put them all together and let's see which one of the one come up top, right? That's what you're doing.
Yeah. So what we're doing in this case is the committee is using pairwise rankings to in this. Let me go here. where is it? Sorry. Yeah, so one more. Yeah, so in here to get those complete rankings, we're using pairwise rankings. So we get an approximate complete ranking for each member on the committee. And then we run the whole algorithm through using these approximate complete rankings. So yeah, in terms of this algorithm, it doesn't really make that much of a difference if you have the complete rankings or not. You can do a version of this with pairwise rankings instead of complete rankings. Just because it's easy to talk about complete rankings. I showed you the complete rankings algorithm.
So this could also be useful, like, let's say I'm designing the poster, right? And I design different version and being able to compare these two and see which one is better.
Yeah, absolutely. It doesn't have to be, you don't have to be ranking people. You could rank things. Yeah, definitely.
Our conference papers.
Oh, conference paper, cool.
Yes. I think the conference papers part I'm really interested in, because you want to see which conference papers are close comparisons to, and that's part of the work of the committee, the program committee, to put them together. So yeah, definitely interested in that.
I have a quick follow-up question. I'm Dr. Z. I don't know if I should explain who I am beyond that, but I work at Atlas. So when it comes to your ranking, I think if you have that pairwise ranking, what seems apparent to me is if everybody has diversity of knowledge on whatever they're ranking, then that pairwise ranking can work. But if you have a very homogeneous viewpoint, how does that fare? And then is there any evidence for how some introduction of randomization might influence like collective biases like that or collective knowledge like that?
Yeah, so this is something that is, we didn't test it in this work, but long ago, I did some research looking at how people from different countries rate people from other countries, right? And this was completely anonymized, right? This was a design class, lots of students from around the world. And then we asked them to rate the prototypes that people made from other parts of the world. We found that people rate work from their own country higher than those from other countries. And that effect held even if we, even if we removed obvious linguistic identifiers from like if it said Russia, if you just deleted Russia and said from my country, right, it still remains. So it's a deep bias. I don't know if simply randomizing the order is enough to remove it, but I do think that some of the work being done on implicit biases suggests that having an explicit idea, can we train people not to be biased just before they go through this process? I think that might be more helpful, right? So, but I haven't tested that. It's just a hope. Yeah.
Thank you.
Yeah.
I've got one last one. We're almost out of time. I don't even know if this is so far from my field of expertise. I don't know if this is a relevant question, but my experience, at least in the physical world, is that requesters or employers often don't know what they're looking for until they see the field of applicants or candidates or results. And I would imagine that's true in the online gig work too, so that it's hard to imagine a request for a logo design that's competent enough for people to do good responses to it. And likewise, when we're doing this faculty search for candidates, we don't know what we're looking for until the people show up. So we cannot write a good brief. And so does this affect anything, or is your work kind of orthogonal to those challenges?
I think that's a deep question. So I think, so to me, I wouldn't say that it doesn't affect anything, right? Obviously, our system's only as good as what people are reviewing each other for, right? So if you say, I want a logo design, and other people are reviewing each other for logo design, you may not get what you need if you don't need a logo designer. But on the other hand, what I will say is that I have a little bit more hope in our system than the current way where you type in, I need a logo designer, and some algorithm picks out who are the top logo designers around the world. I like the idea of having peer interactions to rank the output more, because there's more human interpretation there, right? So other people might say, yeah, okay, so Mark says he needs a logo designer, but maybe Mark really needs someone who is more, like a developer, or he needs a computational system instead of a design system. I don't know, but having those peer interactions allow for more human interpretation. So yeah, that's the way I see it. But I don't know. We haven't tried it with write the brief and then rate each other. That might be a fun thing to try.
Right, but what you just suggested is almost like inviting maybe the peer review, the program committee, they can throw in different criteria into the pool, right? So maybe I said, I want this like Apple logo, that's the old one because it's nostalgia, and I want this Nike one because it's edgy, and I want this. So maybe like doesn't mean that I know what the employer want, but I could throw something in the pool, say this is how my rank differently. And then if each one of the committee members throwing something, maybe the client would look and say, wow, there's other general things that I haven't seen about. Like I want to have a logo, but I want the logo also to be, I don't know, mysterious or a science-fi.
Yeah.
Super fun to think about.
It is fun. Thank you for the nice talk.
Sure, yeah.
So
All right.
exciting. Okay.
Stop
I think we
shitting
learned